Hello children, in the previous classes we discussed the numericals based on current electricity. As we all know very well that children, this chapter has 3 units and related numericals which we have. So numericals based on unit A, numerical based on unit B, numerical based on unit C. So unit A numericals we completed and it comes to the unit B numericals children. So as almost 31 numericals are there in unit B, in the previous class we could discuss only up to 20 numericals and the rest of the numericals which we are going to cover in this video. So the numericals based on unit A and the numericals based on unit B up to 20 numericals. The related links will be given in the description. Just go through those numericals before going to watch this video. Children, before going to start today's numericals from 21 numerical to 31, almost 10 numerical which we are going to solve. So let us recall one important point. Very important. Let us have one important formula, I can say that. So children, for suppose here two resistors, let us say the resistor 1 whose value is R1 and one more resistor whose value is R2. Both are connected in series. Children, we know that when you can say that resistors are connected in series, if same current can flow through the all resistors, then they are said to be in series. But dear children, in a series combination, whatever the potential will be there across the source, that will be divided among the resistors. Let us say V1 is a potential difference across R1 and V2 is a potential difference across R2. So in exam, they will ask us to calculate V1 value and V2 value. So children, here V1 is equal to V R1 by R1 plus R2, whereas V2 is equal to V R2 by R1 plus R2. So this is how we can calculate the potential difference across each and every resistor. If the two same resistors, for suppose, if they are connected in parallel, let us say if they are connected in parallel. So these two resistors with a resistance R1 and R2 are connected in parallel, children. So in a parallel connection, what will happen, children? In a parallel connection, potential difference will be same across each and every resistor. But children, whatever the current is flowing, that will get divided among the resistors. So then how to find the current in each branch? So how to calculate the current in this branch, that is R1, and how to calculate the current I2 in this branch? So children, here I1 is equal to I into R2 by R1 plus R2, and even I2 is equal to I R1 by R1 plus R2. So these are the very important formulas to calculate the, so when these two formulas are used to calculate the potential difference across each and every resistor when they are connected in a series, whereas these two formulas which we use to calculate the current in a different branches when the two resistors are connected in a parallel. Children, if you need in detail discussions how we got these formulas, okay, links, in a previous class which we covered. So I'll try to just give that link in a description. So if you want to know, if you want to learn, if you want to understand how we got these formulas, yes, just you go through the links which will be given in the description so that you can understand. Okay, children, fine. Now let us start a first numerical. Means of course today's first numerical, I think it is a numerical 21st numerical. Okay, now fine, children. So as per the numerical, they are saying that, children, 21 numerical, they are saying that two resistors are connected in a series. Two resistors are connected in series. Each value is 6 ohm and here is a 4 ohm, and these two are connected to the power supply or power source of 6 volt. Is it 6 volt only? Yes, it's a 6 volt. No, it's a 20 volt, children. 20 volt. Now what they are saying, they are asking us to calculate the current in the circuit and potential difference across 6 ohm resistor. 6 ohm resistor. Let us say it's a R1, it's a R2. Children, how to calculate the current? If you want to calculate the current, first we must do the total resistance. So it's very clear that here only two resistors which we have, that two both are in series. Then the total resistance will be R1 plus R2. So this will be 6 plus 4, that is 10 ohm. So this is, let us say, it's a EMF. So current is equal to EMF by total resistance, that is 20 by 10. So the answer is 2 ampere. This is a current in the circuit. Okay. Now second one, children. What they are asking? They are asking us to calculate the potential difference across 6 ohm resistor. Let us say across 6 ohm resistor, the potential difference is V1. Across this R2, let us say it's a V2. So just we have seen the formulas. So V1 is equal to V into R1 by R1 plus R2. What is V? Yes, this is actually V. Okay. So this is going to be 20 into R1 is how much? 6 by 6 plus 4. So this will be 120 by 10. So V1 is equal to 12 volt. V1 is equal to 12 volts. Children, as V1 is equal to 12 volt, can you guess V2 is equal to how much? It is, so if there is no internal resistance, so there is no potential drop, then obviously 20 minus 12 will be how much, children? It is 8. So 8 volt will be the potential difference across resistor R2. Okay, now are you able to see this? Just copy it. Yes. Yes, you are able to see that. Fine. Now children, look at here. Question number 22. So numerical number. So as per the question, children, here as per the numerical, two resistors are connected in parallel. Two resistors are connected in parallel. So those values are given 6 ohm and 4 ohm to the battery. Okay, no? Plus and minus. First they are asking us to draw the circuit diagram. So here is a circuit diagram. And they said that when these two resistors are connected in parallel with this battery, 0.5 ampere current. Is it 0.5 ampere? Yes, 0.5 ampere current is drawn. Then the moment when current reaches here, children, definitely the current will get splitted. That is, it is the I1, through this it is the I2. Then they are asking us to calculate the current through each and every resistor. Okay, now let us come on, just beginning of the class we have said, actually we have just recall the formulas. So here I1 is equal to I into R2 by it is R1 plus R2. If you will consider this R1, this will become R2. So then total current is 0.5 into 4 by 4 plus 6. This will be 0.5 into 4 is how much, children? It is a 2.0, that is 2 by 10. So here I1 is equal to 0.2 ampere. Now children, to calculate I2, you no need to use formula. Why? Because the total current, right? So here I is equal to I1 plus I2. So from this I2 is equal to I minus I1. That is how much, children? It is a 0.5 minus 0.2. This is going to be a 0.3 ampere. So through this 0.3 ampere current is flowing, through this 0.2 ampere current is flowing. And this we also can expect, children, how if more the resistance, less is the current. Less is the resistance, more is the current. Okay, children, just copy it. Now let us see the numerical 23. So children, as per the numerical 23, if you can see what is given, here is one resistor is given whose resistance is 1 ohm. And here is one more resistor whose resistance is almost how much is it? 2. It is a 2 ohm is given. Okay, fine. And connected to a battery of 2 volt. They are asking us to calculate the current through each and every resistance. Okay, first we should calculate the total current. If you want a total current in the circuit, what we need to calculate? We need to calculate the total resistance. So here these two resistors are connected in parallel. So we know that in a parallel connection Rp is equal to R1 into R2 by R1 plus R2. So this is 1 into 2 by 1 plus 2. This is 2 by 3. Children, you let it be like this only, so that calculating current will become more simple. So we know that total current is equal to EMF by total resistance. That is, EMF is 2 only. This is 2 by 3. 2 cancel, will go to denominator. So here total current is 3 ampere. Okay. Now current in each branch. Yes. Let us say this is R1 and here is R2. Let us say through this the current passing is I1. Through this current passing is I2. So we have formula, right? I1 is equal to I into R2 by R1 plus R2. So total current is 3 ampere. R2 is equal to 2 by 1 plus 2. So this is 3 into 2 by 3. 3 cancel. So I1 is equal to 2 ampere. Children, as I1 is equal to 2 ampere, I2 is equal to how much? So I2 is equal to I minus I1, that is 3 minus 2. So this is 1 ampere current. Is it clear? Fine. Now we see the numerical 24. 0.4 ampere. Children, it's quite interesting question. In this question, first they are asking us to calculate the total resistance of the circuit. Now when this question is asked, many students will get confused. No need to get confused. Very simple. EMF is given. Ammeter reading is nothing but total current. So here EMF is 4 volt. Total current in the circuit is 0.4 ampere. So we know that actually I is equal to EMF by R. So from this, R is equal to EMF by I. So which will be 4 by 0.4. So if you can simplify, you will get 10 ohm. Very simple. Don't get confused. Okay, this is the total resistance of the circuit, total resultant. Okay, fine. Now second one, they are asking us to calculate the R value. Children, in this entire circuit, how many resistors are there? 2 resistors. And these 2 also in parallel. Now this resultant resistance is the total resistance of the circuit. Already we calculated this. Okay. So as these 2 are in parallel, so look at here. RP is equal to, so let us use this formula. So R1 into R2, that is 20 R by 20 plus R. Children, again I am telling you, here RP is nothing but 10 ohm. You may get doubt, sir, how it is 10 ohm? Please check under. This 10 ohm is what actually? Total resistance of the circuit, equivalent resistance of the circuit. In this numerical, how many resistors are there? Only 2. This RP is nothing but the equivalent resistance of these 2 resistors. So this is nothing but RP only. So this value in the place of RP, what I should write? Here I can write directly as a 10. Do the cross multiplication. 20R is equal to 200 plus 10R. Get this 10R, this is 20R minus 10R. It will be 10R is equal to 200. So R is equal to 20 ohm. R value is 20 ohm. Fine. Now, third one, they are asking us to calculate the current through this value. This how much ma? Okay, now we got 20 ohm only. Okay, na? So let us say it is a R1, it is a R2. Anyhow, both resistance is same. Now let us say through this I1 current is passing, through this I2 current is passing. So now I2 is equal to I into R1 by R1 plus R2. Total current in the circuit is how much ma? How much? 0.4. Okay. R1 is 20 only by 20 plus 20. This is 0.4 into 20 by 40. 21s are 22s are. So 0.4 by 2 will be how much ma? 0.2 ampere. This much amount of current is passing. And what is the amount of current passing through this? 0.2 only. Why we are getting the same current in these 2 resistors? Because their resistance values are same. Okay, na? Just copy it. Now we see the numerical 25. R is equal to how much? Children, look at here. So this question is quite interesting. Direct resistance is not given. So they are talking only in terms of a length of the wire. But for us here one clue is given. What is that here? 1 meter wire resistance is 3 ohm. Try to understand. The wire of length 1 meter, its resistance is 3 ohm. So that we have to keep in mind. Okay, now come to the part A. They are saying that there are 3 wires whose length is 1.5 meter. Means each length of each wire is 1.5 meter. Then what is the resistance ma? R is equal to 1.5 into, for 1 meter 3. So this is 4.0 ohm resistance. Means the resistance of each wire of length 1.5 meters is 4.5 ohm. Now they are saying that these 3 are connected in parallel. Then what is the resultant resistance? How many number of resistors are lengths are connected, wires are connected? 3. Resistance of each wire is how much? 4.5. So direct our formula we have Rp is equal to R by N. This will be 4.5 by 3. So this will be 1.5 ohm. Clear? Fine. Now in a part B it is said that, so one of these wires, what's the wires that is with a 1.5 meters length is connected parallel to the battery such a that the current drawn is 2 amperes. Then they are asking us to calculate the potential difference. Children, here length is 1.5 meters, then resistance is how much? 1.5 into 3, it will be 4.5 ohm. So current is how much? Okay, current I, right? So current I is equal to 2 ampere. Now we know that I is equal to, so V is equal to IR actually, right? Very simple. So V is equal to I into R. I is 2, R is 4.5. This will be 9 volt over. Simple, don't make it complicated. Okay, now fine. And I come to the part C, children. So here very clearly said that a wire of length 5 meters. Then what is the resistance? Very simple. Resistance is 5 meter means scalar like this. 5 into 1 meter, yes. 5 into, try to understand. 1 meter resistance is how much? 3. So it is 3. So no, write 1 actually. Okay, fine. So this will be 15 ohms. So the wire of length 5 meters has a resistance of 15 ohm. Now they are saying that if the area of cross section is doubled for the same length 5 meters, what is the new resistance? Children, let us say new resistance is R dash. Children, try to understand. Whenever resistance is, area of cross section is doubled, resistance will become halved, means half of its value. So that is 15 by 2, which is equal to 7.5 ohms. So simple manner you can do it. Okay, now don't get confused. Copy it. Now question number 26, EMF comma R, children. So children, as per the question, children, first 2 resistors with the same resistance 2 ohm only, when they are connected in a parallel with one battery whose EMF is given interrelation. These two are unknown. When these two are connected in parallel with this cell, 1.2 amperes current is drawn. But whereas same 2 resistors with the same cell, but now they are connected in series. When they are connected in series, 0.4 ampere current is drawn. So if it is a situation, then they are asking us to find the EMF and the internal resistance of the cell given. Okay, fine, children. So let us recall one formula, children. What we have actually, EMF is equal to what we have here, terminal voltage plus potential drop. Okay, EMF is equal to terminal voltage can be written as total current into external resistance plus potential drop is equal to total current into internal resistance. So now this is a common formula which we are going to use for both cases. In both cases we use the same formula. Now look at it. For this, first let us apply for this. For this, what is the R? R is what actually? External resistance. If 2 resistors are there but which are in parallel, children, if 2 resistors are connected in parallel, what is the common formula? R1 R2 by, it is R1 plus R2. So this is 2 into 2 by 2 plus 2. So Rp is equal to here 1 ohm. The 2 are connected in series, right? So Rs is equal to R1 plus R2. So that is 2 plus 2, which is going to be 4 ohm. Now let us apply the same formula here. So epsilon is equal to, so here I into, so that is 1.2 into 1. Okay, or else here we can take I as a common, right? That is 1.2 into R is 1 plus smaller, let us say equation 1. And here if you can apply EMF is equal to I, you can take as a common, but here I is how much? 0.4 into R is 4 plus R, that is equation 2. So from these two equations, as LHS are equal, RHS can be equated, right? So let us equate these two now. So 1.2 into 1 plus R is equal to 0.4 into 4 plus R. So here 0.41s, 0.43s. Okay, now with the 3 you can multiply. 3 1s are 3 plus 3 into R, 3R. this is 4 plus R. So get this 3 this side, get this R this side. So it will be 3R minus R is equal to 4 minus 3. So 2R is equal to 1, children. So R is equal to 1 by 2, that is 0.5 ohm. So this is the internal resistance of the cell given. But even we need to calculate the EMF, right? Children, it's very simple. This 0.5 value, either you put in the first equation or you can put in the second equation. So in either of equation you can substitute, you will get. So now let us substitute any equation. So substitute R value in equation 1. So EMF is equal to 1.2 into 1 plus 0.5. So this is 1.2 into 1.5. This will be 1.8 volts. So this is how we can calculate. Children, again I am telling you, two same resistors but battery same. Once they are connected in parallel, one they are connected in series. Then they are asking us to calculate the EMF and internal resistance of the battery. So again I am telling you, be cool, have patience, step by step you go through. Definitely you will understand. Just copy this, we'll proceed. So here numerical 27. Internal resistance is 3 ohm is given. Children, as per the question here, two resistors each with 3 ohm, 6 ohm, both are connected in parallel and they are connected to the battery whose EMF is 15 volt and internal resistance is 3 ohm. Now here 3 questions are there, in fact 4 questions. First they are asking us to calculate the total current in the circuit. Children, as I told you that whenever you want to calculate the total current, first we must calculate the total resistance, which means what? External resistance plus internal resistance. Now here external resistors are 2. These two are in parallel. So remember that. Children, always the total external resistance is always in series with the internal resistance. So first let us calculate this total resistance. So as both are in parallel, so we know that R1 into R2 by R1 plus R2. So this will be 3 into 6 by 3 plus 6. So this is 18 by 9. So this is going to be a 2 ohm. Now this total resistance, this external resistance is in series with the internal resistance. So then the total resistance R, let us say, is equal to, so Rp plus small r, that is 2 plus 3. This is 5 ohm. Now they are asking us to calculate the total current. So total current is equal to EMF by total resistance. EMF is given how much, children? 15 volt by 5. So total current is equal to 3 ampere. Total current is equal to 3 ampere. That's fine. Now children, they are asking us to calculate. So let us name it as a R1 and it is R2. R2. Okay, fine. So here second part, they are asking us to calculate the potential difference across the terminals of the cell. Here you may get a wonder, sir, what is this potential difference? Children, potential difference in the terminal voltage is equal to total current into only external resistance, means you should not include internal resistance in order to calculate the potential difference, so called terminal voltage across the cell. Okay, now fine. So total current is how much? 3. External resistance, only these two are there. So resultant of these two resistors is how much? 2 ohm. This is 2. So this will be 6 volt. 6 volt. Is it clear? Okay, now fine. Now third part, third bit, they are asking us to calculate the current at each and every branch. I mean, what is the current through 3 ohm? What is the current through 6 ohm? So let us say I1. So I1 is equal to I into R2 by R1 plus R2. So here I is how much total current? Total current 3 ampere. Okay. So as per this question, R 6 by 3 plus 6. This will be 18 by 9. So I1 is 2 ampere. So as I1 is 2 ampere, I can say I2 is 1 ampere. Why? The total current is 3 ampere, right? So 2 ampere is going in this. So 1 ampere will go through this. Not believing? Come on, let us check here. So here I2 is equal to I into R1 by R1 plus R2. So this is 3 into R1 is 3 by 6 plus 3. So this is 9 by 9. It is a 1 ohm. That's it, children. It is so simple. Don't make it complicated. Step by step, let us follow that. Okay, na? So this is what actually 27th numerical. More 4 numericals are there, which we will be solving. Just copy it first. Now we will see the numerical 28. Numerical 28. R is equal to how much? Children, this is very important, seems to be lengthy but easy numerical. We need to have a patience. Okay, now fine, children. So this is a diagram given. First they are asking us to calculate the potential difference across 4 ohm. Means across this, what is the potential difference? Children, a simple manner we can do it actually here. We know that V is equal to IR. I is what? Total current. Already is given. R value is this much, right? So this will be 0.25 into 4. So this will be how much, children? 1 volt over. It is a 1 volt. That's it. Now potential difference across internal resistance. Children, potential difference across internal resistance is nothing but the potential drop. So they are asking us to potential drop is equal to total current into internal resistance. Total current is 0.25. Internal resistance 3 ohm. So this is going to be 0.75 volt over. Simple. Now potential difference across either R or 2. Why they are saying either R or 2? Because both are in parallel. When the resistors are in parallel, potential difference will be same. Clear? Fine. So this we have to do logically. So let us say potential difference across this, let us say it's a V1. Across this is a V2. Right? Then the total EMF is equal to, right, one is very important, very means very much important. Total EMF is equal to terminal voltage plus potential drop. Terminal voltage is what actually? V1 plus V2, these two together. So it is V1 plus V2 plus potential drop EMF. So EMF value is 2. Okay. V1 value to be calculated. V2 is, let us say this is V2. We got, sorry, it is a V1. So let us say V1 value, so 1 volt. V2 to be calculated. Potential drop 0.75. So 1 plus 0.75, 1.75. So when it comes this side, V2 is equal to 2 minus 1.75. 1.75. This is going to be a 0.25 volt. So this is a potential, what you can say, difference across either R or 2. Now here, children, very important. They are asking us to calculate the R value. They are asking us to calculate the R value. First of all, children, the very important thing is that here, these two are in parallel, right? These two are in parallel. Okay, fine. So let us take a parallel value is how much? Both are in parallel. R1 into R2 by R1 plus R2. That is 2R by 2 plus R. This is the total resistance. Now, can I treat these two resistors with the equal resistance Rp? Obviously. Through this, how much amount of current is passing? 0.25. Across this, what is the potential difference? Potential difference V2, 0.25. So here I can use a logic of Ohm's law here. So here V is equal to I into Rp. So V is equal to how much? 0.25. Okay. Current is 0.25. Okay. Into Rp. This total we have to substitute. 2R by 2 plus R. Both will get cancelled. This side 1 will be there. Get this denominator this side. So it will be 2R is equal to 2 plus R. So 2R minus R is equal to 2. So R is equal to 2 ohm. Simple. Don't make it complicated, again I am telling you. Is it clear? Just copy it. 28th numerical. Fine. Now we see the numerical 29. Numerical 29. This is 6 volt is given. Children, they are asking us to calculate the effective resistance of the circuit and reading of the ammeter. But the fun thing is that, children, they no need to ask effective resistance, because if you want to calculate total resistance, we must calculate the effective resistance. Okay, fine. Now look at it, children. So this R2 and R3, children, here it is the same path for current. Same path for current means if current will enter in this path, same current will flow through R3 and R2, which means what? These R2 and R3, R2 comma R3, these are in series. Try to understand. These are in series. So if they are in series, 2 plus 4, 2 plus 4, this will be 6 ohm. So this branch, this circuit, I can remake like this. Okay, here is already it is there. Okay, now it is 6 ohm. Now this is 6 ohm. Fine. Now these two are in parallel. These two are in parallel. So here Rp is equal to, so 6 into 6 by 6 plus 6. This will be 36 by 12. So this is 3 ohm. This is 3 ohm. So now the total resistance of the circuit is 3 ohm. So finally this circuit I can remake like this. Like this. So with a single resistor is how much more? 3 ohm, and this EMF is 6 volt. Now this is EMF. Okay. This is total resistance. Now we need to calculate the reading of the ammeter. Okay. Let us not forget ammeter. Otherwise who will measure the current, man? Okay, na? Fine. So we know that total current is equal to EMF by total resistance. This will be EMF is given 6, total resistance is 3. So this will be 2 ampere. Okay, na? Copy it. Now let us move to the numerical 30. This is 60 ohm. Children, now this is also similar question to the previous one, means 29, 30. Both are same actually. Circuit might be different, but concept is same. So they are asking us to calculate the total resistance of the circuit. Thereby we have to calculate the ammeter reading. That is what current in the circuit we need to calculate. Come on, children. Here two branches are there. These two are in parallel. These three are in parallel. Let us calculate first effective resistance of these two. So that is Rp is equal to, both are in parallel, right? 10 into 40 by 10 plus 40. So this will be 400 by, it is 50. So here Rp is equal to how much, children? 8 ohm. So this is resultant resistance for R1 and R2. Now let us say this is R3, this is R4, here is R5. These three are in parallel, right? These three are in parallel. So here 1 by Rp is equal to 1 by R1, means these three, 1 by R3 plus 1 by R4 plus 1 by R5, that is 1 by 30 plus 1 by 20 plus 1 by 60. So LCM is going to be 60, 32 is a 23 is a 61 is a, this is 6 by 60, that is 1 by Rp is equal to 1 by 10. So then Rp is equal to how much? 10 ohm it is, 10 ohm. Let us, this is Rp dash, it is Rp double dash. Now this Rp dash and Rp double dash you can treat as one resistor, here one resistor. So now this is a single path for current, which means what? Rp dash and Rp double dash both are in series. So the total resistance will be Rp dash plus Rp double dash. So it will be 8 plus 10, it is going to be 18 ohm. Okay, fine. Now they are asking us to calculate the current. So current is equal to, we know that EMF by total resistance. EMF is given 1.8, it is a 18. So this will be 0.1 ampere. That's it, children. Whatever may be the circuit, here concept is important. So how we are simplifying the circuit is important. Clear? Note on this. Now here is the last numerical in this session. I think video is going to be a lengthy, children, because of course seems to be just 10 numericals only, but each and every numerical we are solving in detail. It might be 1 hour or more than 1 hour. Okay, fine. So this will be the last numerical 31. It is 9 ohm. So children, first two questions are similar to the previous two questions only. So first two sub questions. First they are asking us to calculate total resistance, effective resistance, resultant resistance they are asking. First of all, how many resistors are there? So here smaller 0.8, it's a practical ammeter, it has a resistance, and these two are in parallel. So can I say like this? Total resistance is equal to internal resistance plus ammeter resistance plus the resistance due to these two resistors. So it is nothing, both are in parallel. So Rp. So now first let us calculate Rp value. Rp value is how much, children? So Rp is equal to, so R1 into R2 by R1 plus R2. So with that 4.5 into 9 by 4.5 plus 9. So this will be 40.5 by 13.5. If you can simplify this, you will get a 3 ohm. Now the total resistance will be how much? 1.2 plus 0.8 plus 3. So it is nothing but 5 ohm. So first one is over. Now reading of the ammeter. So total current is equal to EMF by total resistance. So EMF is equal to how much? 2 is given, 2 by 5. This will be 0.4 ampere. It's okay, fine. And here is now task. What is the third one, children? They are asking us to find the potential difference across 4.5. So first, if you can apply Ohm's law, V is equal to I into R, but I value is not known. So first let us calculate the I1. So children, already we discussed, if two resistors are connected in parallel, how to calculate I1 and I2. First two numericals of this session we discussed that only. So as per that, children, let us say through this total current is I. How much? 0.4. Through this I1 is passing. Through this I2 is passing. For sake of our convenience, let us say it as a R1. You treat it as a R2. So then I1 is equal to, children, we have formula I into R2 by R1 plus R2. So I is equal to 0.4 and R2 is 9 by 13.5. So this will be 3.6 by 13.5 ampere. Children, don't simplify this. I will tell you why. Of course, you can simplify, but it will become too complicated. So look at here. Now we need to calculate a V value, right? So that is V is equal to I1 into R1. So I1 value, you can substitute this value 3.6 by 13.5 into R1 is equal to 4.5. R1 is equal to 4.5. So now you can multiply with 4.5. So 4.5 ones are 4.5 threes are. So 3.6 by 3, 1.2 volt. As children, we missed one numerical here. Meanwhile, if missed one, what is that? What is the potential difference across the terminals of the cell they are saying? So children, potential difference is equal to, that is a terminal voltage, total current into external resistance, which means what? You should not add internal resistance. So that is total current is 0.4 and resistance, children. So we have to neglect this R value, which means what? 0.8 plus 3 will be how much? It is a 3.8. So this will be, if you can measure, so 4 8s 32, 15 it is. So 2 points, so 1.52. This is volt. Is that clear? So try to understand. This is a potential difference across this 4.5 ohm resistor, whereas this 1.52 volt is a what we call potential difference across the terminals of the cell. Clear? Okay, successfully we completed, right? We completed the numericals based on exercise B of current electricity. Children, again I am telling you, of course, in this exercise, almost 31 numericals are there. That's what we made the two parts. So previously we discussed 20 numericals. In today's session we discussed the 11 numericals. But these 11 numericals are not tough one, children. I cannot say that they are tough, but they are lengthy type it is. Means one should have a patience to do it. Passion, and it's a what we can say, patience should be there. Is it clear? So again I'm telling you, children, whenever you are solving the numericals, okay na, just have a pen and paper, just practice it again and again. But before going to practice the numericals, first let us go through the lesson and try to just make a note of all important formulas. This is what actually you have to do for every chapter, children. How many important what we can say formulas will be there? Just list out that. Because whatever the numericals which you are going to solve, all are based on those formulas only. So if you have idea about those formulas and if you can understand the concept, then easily you can simplify the whatever the numericals which are given. Okay, so with this successfully we completed the numericals based on unit B. So in next session and the next couple of days, yes, we will be solving the numerical based on unit C. So let us see so whether we can cover all numericals in one session or we need to make 2 sessions of that unit also. Okay children, thank you so much, all the very best.